Alright, 8.3 is trapezoids. We've done rectangles, squares, triangles, parallelograms, rhombus. Let's go to a trapezoid. The area of a trapezoid, the formula is right over here. Now this is when you have it all in one line like this. On like a computer, you write it out like this. If you want to see it this way, it might make a little more sense. You have your height times your base 1 plus your base 2, and then divide it by 2. That's what these brackets mean right here. These brackets that are right there mean that it would be on top of the fraction. This slash is a division, which is this line right here, and this 2 is our bottom of our fraction. So that would be the formula. Now let's see how you get this formula. If I was to take this exact same trapezoid, exact same, identical, and flip it so that it looks like that. So I flipped it upside down. What do you notice now? When I put them together, what does it make? Makes a big parallelogram, a really big one. What's the area of this parallelogram? Base times height. How do I find the base? How do I find this entire base? You add the base 1 plus the base 2 to get the whole base, right? So the area of this parallelogram would be base 1 plus base 2 times the height. But how much of that parallelogram do I really want? I only want half of it to get the trapezoid, so that's how they divided by 2. That's how they came up with the formula. They took two of them together to make a parallelogram. Okay, so then you get your base, you do your base plus base times the height, but you only want half of it because you're looking for the trapezoid. It also works for a right trapezoid. It'll make a perfect rectangle. The rectangle would be the base times the height, so it's base 1 plus base 2 times the height. Again, you only want half of it, so you take half of it and you get your trapezoid. So just to show you how they came up with this formula right here. Now let's use that formula on the first example. Parking lot in the shape of a trapezoid. I made it gray so that you can kind of see that it's a parking lot. Usually that's the ground. Yeah, great. The cost to resurface the parking lot is $1.75 per square foot. $1.75 for every square foot of space in that parking lot. What will be the total cost to resurface the lot? Step 1. We got to find the area. Can't find the cost if we don't know the area, because we're basing our cost on per square foot. We need to find out how many square feet we actually have. So find the area. To find the area, we're going to use our area formula. Again, you might want to write it one on top of the other. 800 plus 1200 times the 447 divided by 2. So you might want to write it one on top of the other instead of all on the straight line here, just so you have it a little easier for you to understand. But you got to find the area first. So you're going to take your height times your height here times your two bases together, divide by 2. So we're going to end up with 800 plus 1200 is 2000. And you end up getting 2000 times 447 divided by 2 is how it's going to end up being. So if you want to write it like mine here, or if you want to write it like straight across, you can. The answer then is 447,000 square feet. Yes, it is. 447,000 square feet is what you get at the parking lot. Now each one of those square feet, and there's a lot of them, there's 447,000 of them. Each one of them is $1.75. So to find the total cost, you're going to find the total cost, step 2. To do that, you're going to need to multiply the 447,000 times $1.75, $782,250. Now, most parking lots are owned by the city that they're in. So you wouldn't have to come up with that $782,000. The city would do that. Now, where do you think the city gets that money from? Taxes, yeah, the sales taxes and income taxes and those kind of things. So that's how they get their money. They use that money to make the roads and to make the parking lots. And I don't know where they prioritize stuff. What roads come first and second? I guess more highly traveled roads and stuff get higher priority. But that's where that money would probably come from, if it's a parking lot. Normally that's the case. Not always, but normally that's the case. All right, we good to move? No? One more?
So you just basically
Mm-hmm. How do I know that 800 and 1200 are my two bases?
get the writing.
Because they are parallel. The right angle makes my height. Okay, the two bases have to be parallel. The height has to be a right angle to those two bases. What do we call the 490? Got a name called the slant height. Slant height. It's not the regular height. You don't use that. There is a time when we're going to use a slant height for stuff, and it's not here. So this is just giving you a side of a triangle if you need it. You might end up using this if you don't know the 447. You might have to use Pythagorean theorem or SOHCAHTOA or something. But this is the height that we need. We need the 90-degree angle height. Okay, photovoltaic cells convert solar energy to electrical energy. So you see the solar cells around. It says the cells completely cover the solar panel. So on this solar panel, there's photovoltaic cells on there. They cover it completely. The solar panel has a shape that's a trapezoid. It's got the two bases, 2.3 and 1.7. Now the cells generate 8 watts per square foot. And 40 watts is required. So 8 watts for every square foot, and it makes 40 watts. So the total power that it uses is 40 watts. The power per square foot is 8. Because every square foot is 8, it's generating 8 watts. The solar panel area is what we don't know. That's our A. We know it's going to make 40 watts. We know it makes 8 watts per square foot. What we don't know is the area. So if we solve for A, what would we get? We get 5 because we would divide both sides by 8, and we would get the area equals 5. So I know now what the area of that trapezoid is. Is that what it's asking me? Am I done? What's it asking me for? The altitude. So I know what the A equals. So if I look at my formula for area, I got H, I got B1 plus B2 divided by 2. If I look at my formula, I know the A, that's 5, I already figured that out. I know B1, that's the 1.7. I used the smaller one for B1. I know the B2, that's 2.3. The only thing I don't know is the H. So I'm going to put in a 5 equals H, 17 plus 2, or 1.7 plus 2.3 all over 2. And if there's just one variable, I can solve for that variable. Bless you. I can get that variable by itself. What do you think we would do first in our Algebra 1 classes to get the H by itself? We could combine like terms. Okay, so I'd put those little connector bar. But what do I have about the fraction there?
Multiply.
Yeah, I would multiply both sides by 2 to get rid of this fraction. So those cancel out. You're going to get 10 equals, and then 1.7 and 2.3 together, 4.0, which is 4. So 4H. So divide by 4, and you'll have H is 2.5, and that would be feet, not square feet. The 5 up here was the square feet. It's 5 square feet of area. Each square foot is going to give us 8 watts of power, and so that would be the 40. So if the area was 5, then we had to plug in the 5 and then the 2 bases to get our altitude. We got the altitude, came out to be 2.5 feet. So if this right here is 2.5 feet, right in there, that would make this whole area come out to be a 5 square foot area. That's what that would happen. That's what would happen with it. All right. We good there? We need a minute more or no? A little confusing. Just because they didn't give us the area, we actually had to figure out the area first. So they had to figure out the area first. Once we knew the area was 5, then we could use our area formula to get the H. So took a little bit of thinking about that one first. All right, moving on to the back side. Area of a trapezoid with the vertices of those 4 points. Now I'm going to give you a second to graph it because mine can graph really fast because I already got it on there. It's right there. So make those 4 dots and draw in your trapezoid. Do you remember the trapezoid that was just on our quiz, Unit 7 quiz? Do you remember how the trapezoid was not straight across like this, was it? It was actually like diagonally like this, right? So if it was diagonally, you're going to have to use the distance formula to find the lengths of the bases. So this is a nice one because you don't have to use distance formula. Basically, you could look and see how long that base is just by counting across because it's horizontal. So if I counted all the way across, I would get 12 units. And you can do the same thing for this bottom base. It's also horizontal. We could count all the way across on that one too. So that'd be 5 units. And since the 2 bases are horizontal, that means that the height's got to be a vertical line, which you can also count. You count straight up and you go up 4 units. So with this information, the area of that should be pretty quick. You should be able to do the bases, well, 4, which is our height, times the bases, 5 plus 12, divided by 2. A lot of times people put coordinate grids on top of a picture so that they can maybe even do the counting, so they can count how long the bases and stuff might be, and the height. In this case, you're going to get 4 times 17 divided by 2, 68 over 2, 34 square units. 34 units squared. So that's just the area. Now, if we wanted perimeter, if you wanted to add up all 4 sides, you would actually have to use distance formula to find these 2 sides right here. Or Pythagorean theorem if you know 2 of the sides. Which, if you know this side is 4, you know that side's 3, yeah, that would have to be a 5 right there. This one you have 2 sides. So yeah, Pythagorean theorem you could work these things up if you needed to get the perimeter. Alright, we good here? Okay, the rest are just some practice ones. So these are kind of things you might see on your homework. These 3 right here, they did not give you the height on. They're requiring you to figure out the height. They're saying they gave us enough information. Let's see if you can figure out what the height is. We know that if we brought down a line straight down right here. Let me change that to this line right here. Okay, so if we brought a line straight down like that, and we put a little box there, because it's an altitude. What do we know about this little triangle right here? Yeah, it has to be, because if this is 90 and that's 45, this one has to also be a 45. So you have to have a 45, 45, 90. And you know that this whole bottom part is 20. That whole thing is 20. If you were to bring one more of those down, like right next to this part right here, and that would make another 45, 45, 90. So you'd have the exact same triangle on each side with the exact same legs because these two legs are exactly the same there. And I know in a 45, 45, 90, this leg and this leg are equal. So if I could figure out this bottom piece, then I know my height has to be the same. How do we get 6? Okay, so the whole thing is 20. You subtract out this 8 right here. So 20 minus 8, you get 12. So these two pieces need to add up to 12, and they have to be the same. So you just take the 12 divided by 2, and they're both 6. So this piece is 6, and this piece is 6. So that means our height is also 6, because the two legs in the 45, 45, 90 are the same. So now we can get our area. 6 times 8 plus 28 divided by 2. 6 times 28 over 2. 168 over 2, which is 84 square feet. So there is your area for the first one. Without the height, we figured it out and we got the area. Second one. Again, I'm going to bring an altitude straight up here. Even though this is an H, this is also the H. But I don't have it in either place. So it means I have to figure it out. I got to figure out what that altitude is. I've got a right triangle, which will help me. Do I know any of the pieces to my right triangle? Yeah, I know that the whole thing is 20. But I crossed that out because it's a little too close. I know that this piece right here has to be 6. Okay, so 20 minus 6 tells me that the other piece is 14. So I have one side of my triangle. Now, it is a 30, 90, and 60, right? Because 30 and 90, well, this would have to be 60 down here. If you like the 30, 60, 90 formulas, then use them. Because to get the H, if you know them, if you don't like off the top of your head, you're going to take 14 and divide it by radical 3 and get that height, and you're done. But if you don't know them, what do you got to use? You got to use SOHCAHTOA. If you're not sure, you're going to be thinking about SO, CA, or TOA. And in this 30-degree angle, the H is my opposite, and the 14 is my adjacent. So I got to OA, I got to use TOA. I don't have the H, so I don't need the SO or the CA. So I got to do tangent of 30 equals the H over 14. You're going to multiply by 14 on both sides. So you're going to get 8.1 when you do that in your calculator. Now you could have used 14 divided by radical 3. You got the same answer. If you knew those formulas. Safer way is SOHCAHTOA if you remember. So 8.1 is my height. So my formula then for my area is going to be 8.1 times 6 plus 20 divided by 2. So in our calculator, I'll just do the whole thing in the calculator and get one answer there. So I'm going to do 8.1 times 26. And I'm going to take that and I'm going to divide it by 2. So I get 105.3. And that would be square inches. So we had to use SOHCAHTOA to get our height. The third one, what kind of shape is the third one? It's isosceles. Because they're both 50s. If these two are the same, then these two are going to be the same. Now I know in the picture they don't look great as far as being the same, but they are the same. Those two would have to be the same in this picture. I'm going to draw in an altitude. Okay, so I drew it in altitude, and I'm going to put h there. And I need to solve for h in order to get this one. Can I use a 45 or 30, 60, 90, or do I have to go straight to SOHCAHTOA? You got to go to SOHCAHTOA. This is a 50-degree angle. There's no special triangle with 50. So we need to find out what this, the whole thing is 36. That means this piece from here to here is 22. So what's 36 minus 22? You get 14, right? Divide it by 2 because there's 2 equal pieces, and they're both going to be 7. They're both going to be 7 there. So if you look at it, 7 plus 22 plus 7 would give you the 36. Now we know our leg, so we can do the opposite and the adjacent. So once again, we're going to need tan. So tan of 50 equals the opposite h over 7. Multiply both sides by 7. So you got 50 tangent. You got the tangent of 50 right there. You're going to times it by 7. You're going to get 8.3 for your height. So your formula then is going to be 8.3, 22 plus 36, divided by 2. So we're going to do the 22 plus the 36. That's going to, oops, that's not plus. 22 plus 36. That's going to give you 58. You're going to times that by 8.3. That's going to give you 481.4 divided by 2, 240.7. And that would be square centimeters. So those are 3 that they didn't give us the height for, but we could find the height simply by using SOHCAHTOA or the 45, 45, 90, possibly Pythagorean theorem if we would know 2 sides. So different ways that we could find the height, but you need to be able to use stuff that we've done in the past to be able to find the height. All right, moving on to the last 2. Last 3, 4, 5, 6. Can I move it? Almost there. I'll read the next one and then I'll move it. The area of a trapezoid is 225, so they're giving us area. Altitude is 10, they're giving us the altitude. The longer base is 30, so they're giving us B2. Find the shorter base, so they're missing B1 this time. So in this problem, right here, we use our formula, height, base 1 plus base 2 over 2. They're giving us the area. They're giving us 225. They're giving us the height as 10. They're not giving us B1, but they are giving us B2 as 30. So those are the pieces that we've been given. We're missing the 1B. Again, Algebra 1 has told us how to solve for that B. You think back to your Algebra 1 days, you just keep doing the same thing on both sides until you get that B by itself. So in this case, I would multiply by 2 because I want to get rid of this fraction. This gives me 450 right here. I would then distribute next. So I would have 10B1 plus 300. When you subtract 300, you're going to get 150 here. 450 minus 300 is 150. What do you get when you divide both sides by 10? You're going to get 15. And that's going to be 15 meters is your smaller base. You could always solve for one piece, as long as you have all the rest of them. You've got all the rest of the pieces, you can find one. Trapezoid has one base that's 8 longer than its other base. So if we draw a quick little trapezoid here, one base is X, the other base is 8 longer than that. The bigger base is 8 longer than the smaller one. So you got to use x plus 8. If you made your bigger one x, then this would have to be x minus 8, because it's got to be smaller. But I'm going to use x and x plus 8. And it tells us the height is 3. So you draw a line right there with a box. That's a 3 right there. It's also telling us the area is 24. So they're giving us plenty of pieces. We're just going to plug it in and solve for x. Try to figure out what x equals. So area equals, we got h, b1 plus b2 over 2. So we're going to plug in the pieces that they gave us. They gave us a is 24. They gave us h is 3. They gave us b1 as x. They gave us b2 as x plus 8. And divide the whole thing by 2. So just get x by itself. Solve for x. So multiply by 2. And these 2's will cancel out. You'll get 48. And we have, when we distribute here, we get 3x plus another 3x. So I'm going to put 6x rather than put the two 3x's. So I could have combined these already, got 2x, and then 3 plus times 2x would have been 6x. 3 times the 8 is 24 over here. When you subtract 24 on both sides, you're going to get 24 equals 6x. When you divide both sides by 6, you're going to get x equals 4. So that means in our problem, the short leg is 4. And then 4 plus 8, the long leg is 12. Bless you. So we've got our short leg is 4, we've got our long leg is 12. Is the long leg 8 longer than the short leg? Yes, it is. It works. And the area would be 24 in that one. So that is the right answer. Those are the right answers. The last one. So the high school building, high school is building a new athletic field in the shape of a trapezoid. What length of fence will be needed to enclose the field? How do I figure out that? That's perimeter. How much fence is needed to keep all the students inside? We don't want you guys escaping or anything like that. No. So we want to get the perimeter. P equals 195 plus 175 plus 150 plus 300. Now I think the answer is 820, but you might want to check. Double check if you have a calculator, but I believe it's 820 just yards. But do a double check in case. 820 is just a linear measure. It's a line around the field. So that would be in just yards, not square yards. The second one is asking for the square yards. So is 820 right? Yeah, okay. How many square yards of sod is needed to cover the field? So to get the square yards, I'm going to use my area formula. Height times base 1 plus base 2 over 2. So what are my numbers? What's my height in this one? 300 is the height?
No.
150 is the height. No, 175 is the height?
No. 150.
So, but I thought the height had to go up.
No, because the lines are not perfect.
So the height doesn't have to go up? No. Okay. So what you're telling me is that this 300 is parallel to this 175. That makes those what? Bases. That's correct. The bases are always parallel. The height just has to be at a 90-degree angle from those bases. And down here is where your 90 degrees is. So you're right, 150 is your height. 150, that means base 1 I'm going to use 175. Base 2 I'm going to use 300 divided by 2. And I would do that whole thing in my calculator. I do 175 plus 300. I would times it by 150. And then I would divide by 2. Get 35,625. And that would be square yards. So that one's a problem where you might use square yards because it is a big, very large area. So you might want to use square yards for that. All right, 8, 3 is done. The homework is 8.3 tonight.